Sagar from AML section, and my topic is unleashing the power of process in operating systems. So, the invisible conductor, operating systems as orchestrators, shameless coordination. These operating systems OS coordinate software processes like a conductor leads an orchestra. So ensuring every instrument plays in harmony. So there's simultaneous management. They exactly experimentally management this multiple programs are running simultaneously, ensuring efficiency and responding without any conflicts. There's preventing chaos. This preventing chaos is without the OS orchestration, software components would let me move my slide. Would clash, leading to the system chaos, crashes, and unstable performances. So this preventing chaos are more important for operating systems. So, what is a process orchestration in computing? Beyond simple automation, orchestration means that automated coordination and management of multiple software tasks uh, and systems. Unlike simply automation, which executes a single task, orchestration strings together complex workflows. So, OS process management, the heartbeat of software execution. It is called as the heartbeat because the process is the heartbeat of software execution. So, process life cycle. How's the process life cycle and inter-process communication and dynamic scheduling? The OS creates schedules and terminates process intelligently, allocation CPU time fairly among them, and the inter-process communication is nothing but it adaptively handles the communication between process, ensuring that seamless synchronization and efficient resource sharing. There's dynamic scheduling. For example, the Linux kernel's associated scheduler activity balances thousands of processor every single second, optimizing a single system performance. And from threads to multitasking level, how the OS orchestrates parallelism. So this slide gonna be this multitasking from threads. So thread management. The OS efficiently manages multiple threads within process, enabling smooth multitasking and keeping applications highly responsive. So resource optimization. It orchestrates CPU cores, memory, and input-output devices to maximize the system throughput and deliver in peak performance. It gives a peak performance. That peak performance word says that it gives fast and solutions, and it is the faster performance. The process gives the faster performance. This is a global scale. Modern OSS, operating systems like Windows 11 and Android 14, engineered to optimize for billions of concurrent tasks globally, demonstrating this incredible scalable tasks. So orchestration versus automation. Automation. Why OS does? So this automation at its core. The OS automates many repetitive foundational tasks such as dynamic memory allocation and effective file handling and management hardware interactions. So this layered orchestration. What is the layered orchestration means? This crucially the operating systems then orchestrates these automated tasks into a seamless, interconnected software lifecycle, ensuring completely like applications run reliably to the manual inventions that run according to a manual lifecycle and which is given. And the real world impact, the OS orchestration in cloud and container environment. Container platforms. OS level orchestration is the backbone of container platforms like Kubernetes. managing the entire life cycle of modern applications. This Kubernetes has the అంటే it is the uh, it can manage the entire life cycle of modern applications like the applications we are using right now for the user interfaces UIs we are using right now. In that case, this operating systems level orchestration is the backbone of this Kubernetes. So, cloud orchestration. This cloud OS orchestration automates the scaling, deployment, and ensures fault tolerance across a vast distributed system. This fault tolerance is nothing but we can say that the data may not be exist, but it loads the data and it may display it through these cloud orchestrations and container platforms. These industries influence all the real-time world examples for these operating systems, and in that main operating systems about the processor and what's the processor important and the power of process, a small process, how it's gonna generate these um, uh, these platforms, and how many these runnable states of this industry influences. Like Google Pioneer Borg systems directly inspired Kubernetes and some other like Testaments to be ability to orchestrate millions of containers daily are unplanned efficiently. So in this industry influence, there are many. And the challenges in OS process orchestration is concurrency management. The concurrency management is nothing but the sophisticated algorithms are essential to effectively handle deadlocks, race conditions, and resource starvation in multi-threading environments. And the next point comes to security orchestration. The OS must meticulously isolate process to prevent malicious interference and mainly system integration and this continuous adoption. The OS orchestration strategies must continuously evolve to efficiently support emerging technologies like AI workloads and distributed edge computing. And the processor is the main device for all these OS processing architecture orchestration. This processor is main thing, and the parts in a processor processes the data and it generates and it works efficiently with these management and adoption systems. Like the future, what's the future on this process? We can talk a lot from these future ways, but I'm going to make it short on that. Smarter OS orchestration with AI and automation. When the processor and this OS got this AI features, then AI-driven optimization, hybrid integration, autonomous ecosystems. This AI will enable OS or orchestrations to pretend resource needs and dynamically optimize scheduling of peak performance. These when this AI enables this operating systems are this operating systems implements includes this AI, so the performance will be at its peaks. And this hybrid integration, seamless integrations with cloud architectures platforms with unlock powerful capabilities for managing complex hybrid environments. In these complex hybrid environments that manages many powerful unlocking the many powerful capabilities in this cloud orchestrations that autonomous eco-friendly ecosystems. The vision fully autonomous OS orchestration, creating zero downtime, self-healing software, so an ecosystem and that adopt and evolve independently. So this autonomous ecosystem that vision, the vision is fully on OS orchestration with a zero time fall and healing the software from economy system to the next generation without any dependency. So, yeah, By these, the OS with the AI gonna make this performance it's better. And here are the challenges. Let me revive the PPT ones. So the this is the operating systems and some preventing chaos, simultaneous management, and how the process orchestration in this computing world. And next, the life cycle of process and the computer inter process communications and dynamic scheduling, and how it works on threads, and the differences between automation and the layer orchestration, and the real world impact, how it impacts on the real world with the process, how it process in the real world, and what are the challenges and concurrency management, continuous adoptions and security is the main challenges that OS processor orchestration. And the future, we had discussed about this future that for a processor, for a smarter OS in the future, next generation, this AI driven optimization will gonna its peak, because AI compared to present technology, the AI is the advanced technology, artificial intelligence. With these artificial intelligence, we combine our processors, and if we did a project, it will be at its peak level results we get from this, the unsung master of software harmony. This is the uh, understanding that how the software processes, how it's gonna process, and let's recognize the OS as a ultimate conductor, truly unleashing the full potential of modern computing. This says that when AI is involved in this processors, then next the modern computing will totally change, and the potential of this modern computing gonna at its peak. So this is my presentation about this power of processor in operating systems. Thank you.